Hey guys, what's up? And I hope you're all doing well out there. So here we're gonna have a look at the maths paper 1 pure maths, and this is for the AS maths paper. So try not to be confused with the actual paper 1 for the just the pure A level. For this syllabus, they've actually split this up. So now if you're doing AS, you will not be sitting the same paper as those from doing the full A level, and the questions are also quite different. As you can see, with question 1 you're doing with tangents, but the question for the other paper, for the other sample, was actually to do with differentiation and calculus and so forth. So without further ado, let's kick in. So here we're going to do a complete walkthrough, and as usual, we have 2 hours. Well, not as usual, this is the first time. But yeah, let's jump in. So number 1. So the line L passes through the points A and B with each given coordinates. Find an equation for the line L. Okay, so I put a nice little hint there which says y equals mx plus c. Now, when you have an equation like this is a straight up tangent or straight line equation cutting through 2 points. So always visualize 2 points like here, like A and B, and then just draw a line connecting them. That's how I do it. And I always think this is a straight line because it's meant to be a line. Now, when you want to use y equals mx plus c, all we need is the gradient m. To find the gradient m, it's just simply the change in y over the change in x, so the change in y coordinates over change in x. And looking at the coordinates here for A and B, we can see that y is 1 and minus 2. So the change here will be 1 minus 2. And the change in x would be 3 take away 4. So 3 minus 4. That's it. And now when you put this in the calculator, well, you should get 3 over minus 1. So the gradient here is minus 3 over 1, or minus 3. So that's easy. Now, therefore, all we do is just plug this back into our equation so far. So we're going to have y equals minus 3x plus c. Now, this is what we got so far. Now, all you want to do is find what c is. Well, a nice way to do this is firstly rearrange the equation to make c the subject. So if I plus 3x across, we're going to have y plus 3x equals c. Now, all we do is just pick any pair of coordinates and just plug in the values of x and y, and voila, you get c. So I want to go ahead and pick A because it's easier. So when x is 3 and y is 1, we're going to have 1 plus 3 times 3. And this is going to give us 1 plus 9, which is 10. So therefore, C equals 10. And that's it. So therefore, the equation for L is y equals minus 3x plus 10. Voila. This is one way to do it. And of course, there's always various other ways. But let's go. Okay, number 2. Ooh, this is easy too. So the curve C has equation over here, which is a nice good old quadratic. Now here we need to find the gradient of the curve, which is here, y equals 2x squared and so on, at the point P where x is 5 and y is 6. Now easy. To calculate the gradient, all you have to do is realize that firstly, the gradient is always used as the letter m. And m in this case equals dy over dx. It also equals the change in y over the change in x, as you've seen in question 1. Now, when it comes to an equation like this, like quadratics or cubics, you could use both, but in my case, I would just use dy over dx. I would differentiate this equation, firstly. So let's go ahead and differentiate. So 2x squared becomes 4x. The idea is to drop the power down and subtract it by 1. Next one, 12x becomes just 12, so it'll be minus 12. And finally, 16 becomes 0. And that's it. Now all you do is realize that you want to find the gradient at this point. So we could say, alright, so at point P, we know that we have x is 5 and y is 6. Well, you only have x to use. So we could say therefore m equals 4, and then at the point x equals 5 minus 12. And that's it. Then you just plug in. So you got 4 times 5 is 20, minus 12 is 8. So the gradient of the curve at this point P, when x is 5, the gradient is 8. And that's it. Easy stuff.